we're going to look at another problem that involves solve, and this time we're not going to solve it like we did in the last question similar to this, using difference of 2 square, converting the 2 to a perfect square by introducing square roots of 2. So that's a simple way of doing it. But this I want to see how to do it using rationalization. Okay, and in rationalization you look for the conjugate of the solve you want to eliminate. I want to eliminate this root 2 because if I substitute root 2 here, I'm going to have root 2 minus 2, which is 0. That's what we don't want. So to rationalize, what I need to do is to change this sign to plus, use it to multiply the top and the bottom. There's numerator and denominator. If we do that, so let me state it by rationalization. We have limits as x tends to root 2, x squared minus 2 over x minus root 2 times, changing this to plus, we have x plus root 2 over x plus root 2. You know this is 1, so we can still go back to the expression. So, but we don't want to cancel it. Instead, we're going to say this times this. When we multiply this, we are going to have limits as x tends to root 2, x squared minus 2 times x plus root 2. We don't need to expand because expanding will waste our time. So we'll go to the denominator. We apply difference of 2 square. Difference of 2 square, which we looked at earlier, we looked at it from a different direction. So right now we want to reverse it. Okay? Generally, difference of 2 square says a square minus b square is equals to a minus b, okay, times a plus b. This is difference of 2 square. A minus b times a plus b. Okay? Which means if I have x square minus 2 square is equals to a minus 2 times a plus 2. Similarly, if I have x square minus root 2 square is equals to x, sorry, I use a instead of x here. It's going to be x. Okay? Are we good? Then here we have x minus root 2 times x plus root 2. So if you observe the denominator, that's what I see here, x minus root 2 times x plus root 2, which means this 2 is what we have here. So we can replace it with this. So that means I'm going to have x squared minus root 2 all squared. Is it okay? So from here, we're now having limit as x tends to root 2, x squared minus 2, because the square will cancel the square roots. So I have x squared minus 2, x plus 2 root 2 all over x squared minus 2. So this is gone. Are you seeing it? Once you rationalize completely, you will cancel out the part that is causing the issues in the solving. So right now, I have limit as x tends to root 2, x plus root 2 over 1. I cannot substitute, so I can ignore the over 1. If I should substitute now, I have x, which is root 2, plus root 2. So x root 2 plus root 2 is 2 root 2. So this is the solution to this question. So this is a problem of rationalization. So sometimes some of the problem can be solved using rationalization, especially when it involves a solve. I'm going to take another problem that involves a solve. That one is more complicated than this. So let's see how we'll solve it. Having in mind what we did here, reversing the difference of 2 square. So difference of 2 square, 2 cube, they are reversible. The direction that favors the solving is what we use. Okay, so let's go. Okay, let's take a look at this other problem that involves rationalization. And if you look at the board, it doesn't exactly have square roots. But if you are familiar with indices, you will see a power that says 1 over 2. And when there is a power of half on both of the term, what you need to do is to change, you can change that power half to the square roots. Okay? Because that's one of the law of indices. So if I do that, We're going to have limits as x tends to 5, x minus 5 over square root of x minus 4 minus square root of 6 minus x. Is that okay? Definitely you should know by now that the denominator, if we substitute 5 directly, will give us 0. That's why we have to simplify. So for me to break this down, I will rationalize by the denominator, just as I explained in the previous problem. So to rationalize this, we change to plus, which is the conjugate. So I use it to multiply the numerator and multiply the denominator. So we have something like this. Limit as x tends to 5, x minus 5 over square root of x minus 4 minus square root of 6 minus x times. So I'm changing this to plus. Now give me roots. X minus 4 plus roots x, rather 6 minus x all over root x minus 4 plus root 6 minus x. So if you look at this, just as we did the first case, the numerator can come together. There's no need to expand so that we don't waste time. So since I'm not expanding the numerator, I have limit as x tends to 5, x minus 5 into root x minus 4, root x minus 4 plus root 6 minus x all over. So this will be difference of 2 square. Take note, most likely when you rationalize the denominator, if the denominator is carried solved, what will happen is that all you need to do is to just square each of the roots and take their difference. When you do that, the roots will be eliminated. So if I take this one, the first one will be x root x minus 4 squared minus root 6 minus x squared. That's what the product of these two will give you, because it's difference of 2 squared. Are we okay? If you don't quite, if what I just said is not clear, you can leave it on the comment section below, and maybe I have to use another video and explain the detail rationalization so that you understand what I'm talking about. But nevertheless, anytime you face this, if you go back to the previous question I solved now, you will discover that it's exactly the same thing I did. Anytime you see root a minus root b times root a plus root b is equals to a minus b. This is as a result of, okay, let me take it this way. This is as a result of root a square minus root b all square. You take each of the term, the difference, all square. And when you square root a square, you have a, root b square, you have b. So this is where we're going to arrive at. Okay? So in that case, it's supposed to be limit as x tends to 5. We're now having x minus 5 with x minus 4 plus root 6 minus x all over. Okay? So at the denominator, what is remaining here now is x minus 4 minus 6 minus x. If you notice, I'm careful to put the term after the minus sign in brackets. Because if I don't do that, the effect of minus will not reflect in my solving, and that will cause us to get the question wrong. So now that I've done that, what I have left here now will be limit as x tends to 5, x minus 5 bracket root x minus 4 plus root 6 minus x all over, we have here now x minus 4 minus 6 plus x. Okay, so now this is limit as x tends to 5, x minus 5 with x minus 4 plus root 6 minus x all over. Now we can collect like terms. X plus x, 2x, minus 4 minus 6 minus 10. I will have to take this down. So this becomes limit as x tends to 5. Here we have x minus 5 brackets root x minus 4 plus root 6 minus x all over, okay, all over 2 bracket x minus 5. So you notice we have a common term at the numerator and denominator now. They can just cancel out. So what is remaining is limit as x tends to 5 root x minus 4 plus root 6 minus x over 2. Now we are ready to substitute. Substituting, I have root 5 minus 4 plus root 6 minus 5 over 2. 5 minus 4 is 1. Square root of 1 is 1. 6 minus 5 is 1. Square root of 1 is 1 over 2. So this is 2 over 2, which is equal to 1. Okay? So take your time, go through the solving again. And if you have any question, feel free to ask, drop it at the comments below. I will do my best to go through it and respond.